Hello and welcome. Thank you for taking the time to attend today's webinar about AWS Data Transfer Optimization. My name is Lukáš Flaišhans and I'm the Managing Director of Stormit. I'm joined by Nazar, Špak, who is the Global Business Development Director at Stormit, and also Tomáš, Turek, the Principal Solution Architect at Stormit. Stormit, as the AWS solution provider, has been delivering custom cloud projects since 2013. We leverage the best cloud technology available to provide a solution that is unique to your project requirements. Our services range from helping you build your cloud foundation, design and deploy high availability architecture, to guiding you through migration, modernization, and transformation of your workloads, all the way to cost optimization and cloud value-added reselling. We have helped a number of companies across industries such as iGaming, mobile, video monetization, media, or fintech. Now, today's presentation will go for about 45 minutes. Slides will be available after the webinar via email or SlideShare. There will be a recording of this webinar available on YouTube. And of course, feel free to submit your questions online and we will respond by chat or email. As you probably know, in and out data transfer is an inherent part of AWS Cloud. But sometimes you can be overwhelmed with the cost associated with data transfer outside of AWS. So in this session, we would like to provide you with some practical advice and steps on how to optimize your data transfer out of AWS and lower the cost associated with it. In this webinar, you will learn how to improve your network performance and lower data transfer costs, what AWS Direct Connect is, and how can organizations benefit from it, what are the benefits of using Amazon CloudFront and other Edge services. First, we will talk a little about data transfer out of AWS in general, so we can get a better understanding of it and see the whole picture. Then we will continue by explaining how to optimize the connection with AWS Cloud by leveraging the AWS Direct Connect. What use cases this solution covers and also what benefits it provides. And next we will dig into Amazon CloudFront, what it really is and why we think CloudFront should be part of nearly every project in AWS. And we have also prepared a small demonstration of how easy it is to start and set up CloudFront and how effective the service is. So that's it for the introduction from my side. Nazar, it's yours.
Thank you, Lukáš, for the introduction. So let's start with today's topic. At the beginning, clarify data transfer and data transfer out. Your data is one of the most valuable assets your company has. Utilizing the cloud improves your data's mobility and flexibility to enhance its value. With the cloud, it's easy to move the data where you need it, when you need it. The catch is that moving data costs money, and AWS data transfer costs can add up quickly. Let's take a look at what those costs are and how you can get a handle of them. AWS data transfer costs are the costs associated with transferring data either within AWS, between various AWS services like EC2 and S3, or between AZs, or AWS and the public internet. These data transfer fees are mostly unidirectional. In other words, only data that is going out of an AWS service is subject to data transfer fee. When organization or developer starts using the AWS cloud, they have to understand and accept the fact that they will be charged for a data transfer and will incur a data transfer cost. But why? Why customers should pay for data transfer anyway? The logic behind is quite simple. AWS customers don't have to buy and maintain network cables, switches, routers, and other network elements as they would in their own data center or housing. because AWS will take care of it for them. But in exchange, we'll charge a small fee. The fee is always charged per gigabyte of data transferred. We created this diagram for our customers to explain the data transfer fee structure, to configure the communication within AWS resources or users outside of AWS. We can see here information about type of data transfer and the fee associated. Today, we'll focus on this part, the data that leaves AWS, as this is the most expensive item. Data transfer out, or DTO, to the public internet is charged at 9 cents per gigabyte in Ireland region. It is important to remember that these costs are different for different regions. For example, in Singapore, the fee is 12 cents per gigabyte. DTO fees can destroy the business case of launching the new project or migrating to AWS Cloud. But if we architect properly, leverage multiple services and tools, it's possible to minimize these costs while achieving better performance and security. Let me show you in this simple diagram what I mean by better performance and security so we can understand what threats are and what path the data must take during the communication between AWS and resources or users outside of AWS. On the left side, we have AWS Cloud, and on the right, the on-prem corporate data center. At the moment data leaves the data center, the path leads through a large number of networks, and you run the risk of possible delays, disconnections, or even security risks. Well, the AWS Direct Connect service can help us with both. But what is AWS Direct Connect? It's a dedicated connection to the AWS Cloud, enabling customers to leverage global backbone network of AWS and avoid public internet. AWS has Direct Connect locations around the world. By leveraging the Direct Connect, you can establish a private connection between AWS and your data center, office, or co-location environment, which can in many cases reduce the cost of data transfer, increase bandwidth throughput, and provide a more consistent network performance than in case of sending the data via public internet. As we can see in the diagram, AWS supports two speeds, 1 gigabit per second and 10 gigabits per second, which is more than enough for most use cases. But customers that do not have equipment at an AWS Connect location must arrange for the connection to the Direct Connect location, last mile. So this part is the responsibility of the customer. We here at Stormit, as an AWS partner, can provide you with end-to-end solution and also arrange the connectivity to your current location. So for you as a customer, it looked like this. You manage the router on your side, and you will receive a virtual interface endpoint in AWS. What are the benefits of AWS Direct Connect? The main advantage is stability. Because it is dedicated connection, you can avoid the public internet and avoid unexpected outages and delays. You can choose what data and how you want to send it. You can send some of the data for internal needs directly to your data center or housing. It's elastic because it's possible to increase or decrease the bandwidth throughput capacity or even terminate it completely. And additionally, for an AWS partner, it's possible to establish sub 1 gigabit connection. What's the price? How much does it cost? So AWS Direct Connect has two billing elements. The first is outbound data transfer. Second, port hour. The rate for gigabyte of data transferred is almost 80% lower than for DTO. For each gigabyte transferred via Direct Connect, AWS will charge flat 2 cents, while for a DTO, it would be 9 cents per gigabyte of data transfer for the first 40 terabyte and 7 cents per gigabyte for the next 100 terabytes. So we see huge saving here. With AWS Direct Connect, AWS also charges a port hour, depending on the required capacity. 1 gigabit port costs $240. And as I mentioned before, the customer must arrange the last mile connectivity to a Direct Connect location site, which generates additional costs. And although this might reduce the saving, it's still way more cost-effective solution compared to data transfer out. Let's make a comparison with the help of an AWS calculator. AWS has the publicly available pricing for all services, and this online calculator helps organizations estimate the costs associated with running workloads in AWS Cloud. So let's have a look here. So by default, it's always the region here is Virginia, and we need to be careful about that because the AWS pricing is region specific. So as mentioned before, we will be making all the price estimation based on Europe, Ireland region. So let's select this one. And here we can enter the data transfer out amount. So change here to the terabyte. And let's put, for example, like 30 terabytes a month. It's not a lot, but at the same time, it's a feasible amount that actually will provide us with a good comparison of pricing. Also here, we'll go to Direct Connect pricing. We'll choose 1 gigabit per second. It will be 100% utilization because we'll be using the whole month. Also here, we can see the long list of locations around the globe. And let's take one from Europe that we have here. And for example, let's take Amsterdam as our entry point to AWS global network. And here, data transfer in, it doesn't matter really because it's for free. And here, the most important part is data transfer out. So here we can actually see the costs for the port already. So if you're not even kind of sending anything or not leveraging that port, it's fixed monthly fee that you will have to pay. And here we can add 30 and again change the terabytes. Okay. So it's here, it provides us immediately with the monthly cost, but let's have a look here. So we can see that the data transfer out for 30 terabytes would cost us more than $2,600 a month, and versus Direct Connect service that would cost us around $855 per month. Okay, you have to add some additional costs for having this last mile connection to Direct Connect location, but still we can see that the price difference and cost saving here is significant. Let's go back to our presentation and have a look on some use cases when to use AWS Direct Connect. So the first one, hybrid cloud or hybrid model. Most organizations want to take advantage of capabilities that AWS Cloud offers, but they are unable to migrate quickly or need to retire legacy investments in existing infrastructure. Or, for example, when an organization needs to comply with the regulation and keeps regulated environment on-prem and non-regulated workloads runs in AWS. In these and other cases, AWS Direct Connect will help to ensure communication between the on-prem infrastructure and the AWS Cloud in optimal quality and low cost. Disaster recovery. Organizations use Direct Connect for a two-way data backup to create a disaster recovery solution to ensure business continuity. Because these operations are data transfer intensive, by leveraging Direct Connect, organizations ensure necessary throughput, security, and cost reduction. Latency or latency reduction. With AWS Direct Connect, you avoid the public internet and use the optimized AWS backbone network to achieve lower latency required by some applications such as VoIP. Big data or overall analysis and data processing. With Direct Connect, companies can transfer data faster, more securely, and much cheaper than using other data transfer methods. For example, when data is stored outside of AWS but is sent to AWS Cloud for processing, and once processed, it is transferred outside of AWS again. As we can see, AWS Direct Connect has a wide range of use cases and provides many benefits such as stable throughput, security, and cost reduction. But it's designed for cases where we have a precisely defined other side and is suitable for providing dedicated connection for the operation of internal applications. But what if you run a mobile or web application, game, eShop, SaaS solution, or any other type of workload in AWS Cloud that is intended for the end users on the internet? Direct Connect won't help with that. But AWS has got you covered with Amazon CloudFront for these kind of workloads. But what is Amazon CloudFront? Amazon CloudFront is a fast content delivery network (CDN) service that securely delivers data, videos, applications, and APIs to customers globally with low latency and high transfer speed. CloudFront is part of the AWS global cloud infrastructure and is tightly integrated with AWS's physical locations, as well as other AWS services such as S3, Elastic Load Balancer, or EC2. Now, CloudFront also works seamlessly with other edge services such as AWS WAF and AWS Shield, which will help you mitigate DDoS attacks and other threats. We will actually discuss edge services a bit later. And last but not least, it allows you to reduce costs. But before that, let's talk about how CloudFront works. For content distribution, CloudFront uses a global network of 217 points of presence, so-called edge locations, and that number is constantly growing. And as we can see on the map, CloudFront has presence on all continents. Amazon CloudFront provides a huge number of advantages, and from a performance point of view, here are the most important ones. One of the main advantages is the optimization of the network for optimal performance and speed. Amazon CloudFront is continuously measuring internet connectivity, performance, and computing to find the best way to route requests to AWS network. CloudFront is also running on the AWS Global Network Backbone, as mentioned earlier, and this allows for efficient transfer of requests between the CloudFront edge locations and other AWS services across regions and applications. Network layer optimization such as TCP, fast open, request collapsing, keep alive connections, and much more enable the CDN to accelerate both static and dynamic content for improved user performance. At the same time, with Amazon CloudFront, you can restrict access to your content for a number of capabilities. With signed URLs and signed cookies, you can support token authentication to restrict access to only authenticated viewers. Through geo-restrictions capability, you can prevent users in specific geographic locations from accessing content that you are distributing through CloudFront. With Origin Access Identity feature, you can restrict access to an Amazon S3 bucket to only be accessible from CloudFront. CloudFront can be used even if you acquire an infrastructure that is PCI DSS certified. CloudFront complies with this standard and has obtained other certifications, as we can see below, for example, HIPAA and others. For clarity, just let me show you how CloudFront works in reality. We saw a similar diagram at the beginning of our webinar. AWS Cloud is on the left, but this time on the right side we have the users on the internet, where it's even more difficult to ensure reliable data transfer because users are not in one particular place but are spread over different locations with different connection quality and so on. The number of networks increases and you run into the risk of possible delays, disconnections, and security risks. CloudFront will help us by shortening the way data travels over the internet and bring us close to the end user. So this provides us with more stable and faster communication, and ultimately better user experience. So, in addition, CloudFront is not just a dummy CDN, but on the edge location, it lets you leverage and take advantage of serverless computing power in the form of Lambda functions or integrations with other services that use edge infrastructure such as AWS WAF or Route 53. Because CloudFront is only one of many services from the AWS's Edge Services ecosystem. Here we can see them all. CloudFront as CDN, providing content distribution, static, dynamic, or streaming audio and video. AWS WAF, Web Application Firewall, that protects the application layer from attacks such as SQL injection. AWS Shield, managed DDoS attack protection service, mainly at level 4 and 6. There are also two options. Standard, which is basic, which is always active for all AWS customers without any additional charge, and advanced. It's available at an additional cost, and in addition, it provides you with greater functionality and overview of attacks, and customers will receive access to AWS DDoS team to assist with the protection, and this team is available 24/7. And last is Amazon Route 53, which is DNS service. With the help of these edge services, you can create an advanced security perimeter around your AWS environment and provide better protection and security for your application. What are the typical use cases for using CloudFront? In addition to widely used and well-known advantages of a CDN for caching static content, streaming video, and software distribution, I would like to highlight the less common use cases where it's beneficial to leverage CloudFront, such as security and protection against DDoS attacks, and application layer protection with the help of Web Application Firewall, delivery and acceleration of dynamic content and API, and last but not least, reducing the cost of data transfer from AWS. If you use AWS origins such as Amazon S3, Amazon EC2, or Elastic Load Balancing, you don't pay for any data transferred between these services and CloudFront. We talked a lot about the technical benefits of CloudFront, and now let's focus more on the cost optimization benefit. So if we run an application and store the content in AWS, then we pay for data transfer out. And as I've already mentioned before, in EU Ireland it is 9 cents per gigabyte. We have no control over the data once it leaves AWS region, and we run into the risk of reduced performance and security. Common solution we observed with some of AWS customers is use of a third-party CDN provider. This, in most of the cases, partially solves the performance issue, but results in customer paying twice. First, for the data transfer out from AWS to the CDN provider and sent to the third party. First, for the data transfer out from AWS to the CDN provider, and second, for the third-party CDN provider to the end user. So this is not an ideal solution in terms of cost reduction. However, when customer implement CloudFront and place it between AWS region and the end user, they will be closer to the end user on the internet and have better control over the traffic and overview of data transferred, because they will operate mainly within the AWS backbone network. At the same time, they save on cost for the data transfer, as the communication between the AWS region and CloudFront is free, and they also pay less for the data transfer from CloudFront because the rate is lower. If you are considering deploying a CDN solution, Web Application Firewall, or your goal is to reduce the cost of data transfer out of AWS to the internet, then CloudFront is the obvious choice, especially if you already use AWS. As part of the AWS free usage tier, you can get started with Amazon CloudFront for free. Upon sign up, new AWS customers receive 50 GB data transfer out and 2 million HTTP and HTTPS requests each month for free for the first year. Everything beyond the free tier or after the free tier expires, AWS will charge you based on on-demand rate per region. As with other services, Amazon CloudFront pricing is publicly available on the AWS website. For customers who operate with larger volumes of transfer data and are able to make a commitment, AWS offers reserved capacity, where the customer commits to a certain amount of data and gets better rates than on-demand in return. It's similar to reserved instance for data transfer. Because the CloudFront rate for data transfer varies depending on the edge location, the customer can choose which location they would like to leverage and activate only those with lower rates. For someone who has no experience with CloudFront, its pricing may seem too complicated, but in reality it's not. If you need advice, you can contact us or your AWS representative, and we will be happy to explain everything to you individually and help to estimate the monthly costs or find a way how to lower your existing costs. Now, it's time to demonstrate how easy it is to create an AWS CloudFront distribution and how it can increase the performance. So, Tomáš, I'm handing over to you.
In a practical example, we'll focus on how we can leverage Amazon CloudFront for running static website without having to manage web service and load balancers. Most of today's web presentation are only static websites that consist of HTML files, CSS, and JavaScript files. As a very good example, we can refer to a popular framework, React.js, which is used for creating so-called single-page applications. Most of these applications are running on web servers. Even though the configuration of the servers itself is not very demanding, it has a couple of disadvantages. For example, it is necessary to keep the software that is running on these servers up to date when it comes to various security vulnerabilities, which are appearing over the course of a lifetime. Also, everything fails all the time, so you have to take into consideration that also the static website is not available, or it is necessary to have at least 2 instances running all the time. Better way is to run it using auto-scaling concept. In cases like that, you will have to also have load balancer in addition or some sort of proxy server. Therefore, the total cost of running the application is growing. And yet, such a solution usually runs only in a particular region, so users from other parts of the world are experiencing higher latency. In this practical example, we will use the following AWS services: AWS CloudFormation, Amazon Simple Storage Service, also known as Amazon S3, and Content Delivery Network Amazon CloudFront. AWS CloudFormation will allow us to automate creating of the overall infrastructure, so it is a tool for having an infrastructure as a code. We will use an YAML template for defining the infrastructure. Since it is a text file, we can easily track the history of the infrastructure in the version control system. For storing the actual website content, like HTML files, images, CSS files, and so on, we'll use Amazon S3. This will be our origin in the Amazon CloudFront terminology. To address higher latency for users from different parts of the world, we will utilize Amazon CloudFront, which will be used for distributing the website content and for speeding up the load time thanks to the global points of presence, called edge locations, that are spread all around the world. There are also other important services that are necessary for running a global website. Namely, it is Amazon Route 53 and AWS Certificate Manager. However, we will not use them to keep the example simple. There is usually a need to have a custom domain where DNS service Route 53 will excel. If there is also a requirement for secure communication over HTTPS protocol, we can also take advantage of the service AWS Certificate Manager for maintaining necessary certificates. On this slide, we can see a schema how different services are used together and also how our users' interaction looks like. The first request for loading our website from location A is sent to the closer edge location, or eventually to edge location according to the configuration of our CloudFront distribution. The distribution itself will ensure that the content is loaded from the origin, which is in our example S3. If there is another request from the same location, then the user is served with the content stored in the edge location that was loaded during the first request. Now we can start creating the stack. So first open the AWS console. After logging in, you will see recently visited services in the top part of the console. Down you can see all the services that you have available. So let's open AWS CloudFormation. So we can create a stack. So CloudFormation is a service that will allow us create an infrastructure as a code. So we'll start creating our stack by clicking on Create Stack. For creating the stack, you will use so-called template. My template is already prepared. I have it locally, so I will upload it. You can see that it's uploaded to S3 bucket. So now we can click on the next and type in the name of the stack. So let's create a name. The website. You can also see that there is one parameter that has a default value, web.stormit.com. So we can keep this as is and click on next. On the next screen, you can enter tags, which is very useful concept if you want to later identify the resources. So it's very good to create a tag. So let's create a tag and go next. So now we can see the summary. So template URL, stack description, tags, and other information, and we can create the stack. Okay, now we see an error because we need to enable a capability auto expand due to some inner function that are used in the template. So let's click on the acknowledge capability auto expand, and now let's create a stack. Now you can see that the provisioning of the stack just started. We can also see the template, the final template that will be covering all the resources that are going to be created. You can see website bucket, so it's the S3 bucket, and some parameters like domain name that will be used to name the S3 bucket. And also, yeah, there you go. And now we have the CloudFront distribution with all the parameters. And we can also check the events. So you can see what is the logical name of the resource, the status of the creation, and we can check the state, also the stack info. So you have overall information. So let's go back to the presentation in the meantime, before the stack is created. So you can see again what is going to be created. So we have the distribution, we have the S3 bucket, and we have the users that will call our distribution. So since it's a global resource, it takes some time until it's created. But so let's see if it's done now. So let's go back to the console. As you can see, the stack is created. We can check which resources were created during the process. So you can see that this is the list of resources: S3 bucket, bucket policy, CloudFront distribution, and you have also physical ID and status. Let's see the output. The output, it's part of the template. You can define what will be printed out. It's down in the template. You can see that we printed out the CloudFront endpoint and S3 bucket. So let's go back to our output, and we can later use it to access the distribution or the bucket. But before that, we need to upload some content. to S3 bucket. I have prepared a simple React.js application from the demo, and now I will upload it to S3 bucket. So here is the script. So now it's uploading to S3 bucket, and it's done. The content is uploaded, so we can go back to AWS Web Console and open the S3 bucket. Let's find our bucket. Here it is, web.stormit.com. You can see that access is public. We'll see the content that was uploaded for our static website. And the S3 bucket itself can already be used for static website hosting. As you can see, it's enabled. And we can just, if we click on the hosting, we can find the URL of the bucket. It can be used. Let's open it. So here are React.js demo application that is already hosted in S3 bucket. Now we will also test the CloudFront distribution endpoint. So let's go back to our CloudFormation. Let's open our stack and click on outputs. You can see the endpoint of the CloudFront distribution, and if we open it, we can see the same demo page, the same React application. So now we have two different endpoints. You might be wondering, why do we have these two endpoints? But it's simply because we want to compare and measure the latency of these two endpoints from different parts of the world. So we will use the CloudFront endpoint to test the performance, as well as the S3 bucket static web hosting endpoint to measure it. So you can see the differences, why it's so important to use this CloudFront distribution and not S3 bucket directly. If you have customers or clients all around the world accessing from different parts of the world. So let's take first the S3 endpoint for our testing website. So let's open the S3 console, our bucket, and also the properties of static web hosting. And let's copy the endpoint. We'll use the website that is testing the performance. So it will try to access this website from different location. So let's click that and run the test. Okay. And we will do the same for our CloudFront distribution endpoint. So let's open the CloudFormation, and we will see in the outputs the endpoint. And again, put it in this website and click on Run Test. Okay, now we can see the results from the CloudFront distribution. So let's focus, for instance, on Hungary, Budapest, or other endpoints. You can see the time to first byte and connect time, and you can see different location that was used for testing the endpoint. So let's see the same for the S3 bucket. So you can see already that it's significantly different times when it comes to connect and time to first byte, comparing US, Santa Clara, and we can also check the Hungary, for instance, the Budapest. So let's go back to CloudFront, and as you can see, the time is significantly different than for the S3 bucket. So that's the main benefit you will get if you use CloudFront distribution in compared to simply using one endpoint that is regional. So that's why it's so important to also have attention at this part of the application.
Thank you, Tomáš, for the demo. So, why do you think that AWS customers should include CloudFront in every project? So, first of all, it's AWS best practice. CloudFront is one of the best CDNs on the market, and it helps organizations significantly speed up content delivery. But CloudFront is not just about delivering content. When used the right way, it helped increase application performance, application security, and overall improves application posture. Because CloudFront leverages the AWS global network backbone to minimize traffic over the public internet, it increases speed of the application layer, reduces latency, and provides the ability to leverage compute with Lambda at edge closer to the end user. Thanks to the built-in security features and integration with other AWS services such as AWS WAF or Route 53, it allows you to create an external security perimeter of the application and protect the operating environment. CloudFront is cheaper than Data Transfer Out, and it's possible to get even better pricing conditions with larger volumes and a commitment for 12 or 24 months. CloudFront also allows you to set up multiple origins to enable redundancy in your backend architecture. You can use CloudFront's native origin failover capability to automatically serve your content from a backup origin when your primary origin is unavailable. The origins you set up with failover can be any combination of AWS origins like EC2 instances, Amazon S3 buckets, or media services, or even non-AWS origins like on-premises HTTP server. Let's have a brief summary of our webinar before we wrap up. What options of data transfer out to the internet or on-premises are available, and what are the advantages or disadvantages? Direct transfer out directly from EC2, S3, ELB, and other services. It's difficult to find any other advantage besides speed and ease of deployment. At the same time, it is also the most expensive option for transferring data out of AWS, and we run into the risk of unpredictable performance due to dependence on the public internet. In some cases, it might be also less secure option where organizations can send data from S3 via HTTP or do not have certificates on EC2 and no other layer of protection in place. AWS Direct Connect. It's an ideal solution for establishing a dedicated connection to the AWS Cloud and connecting internal applications, creating a hybrid environment, or in general for use cases where the endpoint outside of AWS is defined. Among the advantages, we can mention that Direct Connect provides consistent and predictable performance. It helps reduce data transfer costs with a lower gigabyte rate. Increases security with dedicated connection. It offers various data transfer capacity options. Ease of use after initial setup and connection. In order for organizations to take advantage of Direct Connect, they have to go through a bit more complicated process and setup at the beginning, since third parties are involved in the process, so it's more time consuming and generates additional costs. And the last one is CloudFront. CloudFront is an ideal solution for projects and applications where end users are on the internet, as its CDN service that secures various data, videos, applications, and APIs to customers and users globally with low latency. Additionally, CloudFront is easy to start with and to set up using the AWS console or CLI. It improves overall application performance, reduces latency. CloudFront also costs less, since the rate per gigabyte is slower compared to the direct data transfer out in most of the regions. It increases the security of the application and environment thanks to the built-in security features, and it also meets the requirements for PCI DSS, for example. It is a scalable solution and avoids single point of failure. It's closely integrated with other edge services such as Lambda at Edge, AWS WAF, AWS Shield, and Route 53. It's difficult to come up with any disadvantages of implementing and using CloudFront. The only limitation we experience is the lack of support of certain protocols or methods of communications, WebRTC, for example. Thank you for listening today to our webinar. I hope and believe that information shared here was useful. In case you have any feedback, questions, or would like to discuss your existing workload and cost optimization, or even new projects you plan to deploy in AWS, Please do not hesitate to contact us so we can discuss and, in case needed, assist you. Wish you a great rest of the day.